So today we are going to solve this problem, validate binary tree nodes. So in this, if you go through the examples here, you have given left child and right child. So like for every node, let's say we have 0 index. So for 0 the left child is 1 and the right child is 2, and for 1 that is -1. So -1 is indicating that there is no child. So for 1 index there is no left child and there is no right child. So let me copy paste this one so that I can explain you better. And yeah, so if I come to 0, then you can see for 0 we have left child as 1 and for 0 right child is 2. Again come to 1, that is -1, means there is no left child and there is no right child. For 2 the left child is 3 and right child is -1, means there is no right child. For 3 -1 and -1. So this one is the tree that we have constructed. So now is this binary tree or not? So we will see like what is the property of binary tree. So we can say a binary tree always has root node, always have root node. And what does it mean to be a root node? So there would be always be a root node, and after that we can say accept the root node, accept root node, every node has parent node. And third we can say no cycle. So these are the properties for binary tree. So let's construct some of the binary tree and we will see whether these are valid or not. So let's say 0 and 1 and 2 and 3. So this is a valid. But if 3 is going again at 4, so this will not be valid, because you can see for 1 is left. So there are two parents for 1, that is 0 and 3. So we can say we have only one parent node should be there. So this will violate these properties. Now let's see one more example, 1 and 2 and this one. Now in that case you can see there is no root node in that case. So root node is always have root node, we can see is a node no edge is coming, only edge are going outside. So that is the properties of root node. It violates the property of root node. And let's construct one more, that is 1 and 2, 3 and 4. 3 is pointing to 1. So in that case we can see we have root node, and for every node we have one parent node. We can say for 2 that is 1, for 3 that is 1, and for 3 that is 2. But it violates the property that there is a cycle 1, 2 and 3. So this makes a cycle, so it is not a valid. This one is not also valid. So if we remove this edge, then we can see it is a valid. This one is valid. So now let's try to build up things. So first of all we need to select the root node. So So what we will do, for root node in degree should be 0. Now if you don't know what is in degree is like how many edges are coming. So let's say for 2 in degree would be 1, and for 1 there is no edge coming, so that would be 0. So if in degree is 0, then we can say this is a root node. So first we will try to construct the in degree array. So let's see the code. Here you can see we have defined one array in degree, and then we are iterating. So I have written this code in Java 8 format, but that is the same thing. So for every left child that is not -1, we are increasing the in degree by 1. And after that, from in degree we are filtering out the in degree that is 0, and we are creating the array. So after that we can see for in degree 0 that would be root node, but root node can't be multiple, or there should also not be a case where there is no root node. So we are returning false in that case, and we are getting the root node after that if the root length is 1. Now after that what we are doing, so we got to know that that is the root node. Now we will try to traverse the root node from the root node, like from 0 we go to 1 and 2, and we will mark them as that is traverse, like this is traverse, it is also traverse, it is also traverse. But if any case we encounter like we have already traversed that, in that case we can say it is not valid, because we have already traversed that node. Apart from that, there is one more edge case. We can say if you come to 1 and 2 is here, so we can say it is traversed, but it is not traversed. In that case we can say it is also not valid. So we will use BFS. So in BFS you use queue. So we insert 0 first of all in queue, and when we pull out this one 0, we will check whether it is already marked or not. We can say it is visited or not. Okay, so if it is not visited, we mark it as visited, and after that we will insert left and right child. So where do we find the left and right child? So we can find that in the array, it is the left node, it is the right node, and we insert that one, and we keep on going doing that. And we also track how many nodes we have visited, and if we visited all nodes we return true, else we return false. I think that's it. Now let me submit the code just for confirmation. Okay, so you can see it is a 17 ms and it is acceptable. So yeah, that's it.